Hello everyone, Noel with AWS here. Last week I touched on utilizing AWS S3 Vector Buckets as your vector database. Today I'd like to expand on that topic and show you some practical applications of utilizing the vector bucket. So AWS introduced the S3 Vector Bucket as a purpose-built storage specifically designed for storing and querying vector embeddings. So unlike your traditional approaches, you don't need to spin up and manage separate vector databases, and vector buckets are relatively easy to get up and running quickly. Okay, so S3 vector buckets cost about 90% less compared to other vector databases and deliver sub-second latency for moderate workloads. Think hundreds of queries per second. For applications requiring thousands of concurrent queries at single-digit millisecond latency, you might still want to consider scaling up to OpenSearch. Okay, so for today's project, I'll demonstrate using the LangChain library to connect to an S3 vector bucket, create an index, and ingest the content. From there, I'll transform it into a RAG-based retriever and wrap it as a tool for AWS Strands. Along the way, I'll show you how to implement metadata filtering on your index content as well. Okay, let's jump into our demo. Now, I've downloaded a couple of PDFs from the AWS developer documentation. One contains EC2 specific information, and the other is a serverless developer guide. We'll ingest these documents into our vector bucket and later demonstrate metadata filtering based on the document type. So each of these documents is about 2,000 plus pages a piece. So let's jump into our IDE. All right, I'm in my IDE and you see my imports. I'm utilizing LangChain to connect to my embeddings model that's coming from Amazon Bedrock and the S3 vector bucket as well, and also to load and chunk the documents. Later, I'll be utilizing the Strands Agents SDK to create a tool for my vector retriever and create an agent wrapper around that tool. Okay, in this cell, I'm defining my bucket name along with the index name and AWS region information. And the process of creating an S3 bucket is pretty easy. So if we go into our console and I go into the S3 service, and on the left-hand menu, I select vector buckets. You can choose to create your vector bucket just by clicking this button, or you can also do it via the SDK. So if I just call it test bucket and sing 2, because I think I have one already created. And at this point, the name just has to be unique within your cloud account. You can specify an encryption type. You can use standard S3 encryption or KMS-based encryption. We're going to create the vector bucket. You can further go into this bucket at this point, define your actual vector index by giving it a name. The dimension is the dimensionality of your embedding model. We're actually going to create our index via the LangChain library, and I've already have it created. You can also select your distance metric. By default, it defaults to cosine, but it can use the Euclidean distance as well. Okay, so let's go back to our IDE here. And now I'm also going to define my document loader. So in this cell where you see I'm defining my document loader, and this takes those PDFs and extracts the text and the key metadata from those files and generates a document type object. And from here, we're actually performing the load operation. So this is executing the document loader, and we store that document object respectively into EC2 docs and serverless docs variable type. Here I'm just running a length of that document object, and you see I have 547 pages. So this is just loading in the data. I haven't chunked it yet. So now if we look at an object, we see that there's page content. So this is the actual content from the page, but then there's supporting metadata as well, right? So there's numerous things like creation date, title, etc. And to get a better view of the metadata, I'll just take a look at that and just filter on metadata, and you see the additional metadata. Now, Metadata filtering lets you narrow down your search results based on document properties, like the type, date, source, and think of it as adding the where clauses to your semantic search. Now, in order to perform the metadata filtering in our demonstration, we're going to add a metadata tag of our own. Note, I could have used these existing metadata tags, but I figured I'd demonstrate this route. So I'm defining a a meta tag called doc type here. And if the document is EC2 related, I'm going to give the doc type a value of EC2. And if we look at the loader for our docs, now you see that it has the doc type of EC2. And if the doc types are serverless related, I'm going to give it the meta tag of serverless. So if we look at the meta tags of the serverless docs, which remember from the doc loader, it's coming from here, we'll be able to see the actual metadata information. From there, we actually chunk our data. So here I'm defining the actual recursive character text splitter that's going to define our chunk size and the overlap size, so the sliding window of those chunks. And from here, I pass those documents in and I actually chunk them up. So I'm going to run both of these processes just so you can see. And then if we take a look at the length of the chunks, now we have an increased number of chunks based on the documents. And from here, I'm going to combine both the EC2 chunks and the serverless chunks into a parent of just chunks. So now I've combined them, but what I have that makes the chunks unique is those metadata tags that I defined earlier. So if we look at the length of chunks, overall we have 859 total chunks. Now, it's important to note Amazon S3 Vector has limitations of a maximum of 10 metadata keys per document. So at this stage, I'm going to delete a few of the metadata keys we won't be using to make sure I stay under that 10 number because that is a limiting factor. So now if I take a look at the number of metadata keys I have now is 9. And I just deleted keywords and page labels because I won't be using that. All right, so previously, now we're going to create a vector store from the document. So I'm just defining my Bedrock embeddings model. I'm using the Titan text embedding model, and I'm using LangChain to access this model via Bedrock. Now, previously, I created the vector store. I just passed my document chunks, the embedding model that I defined, my vector bucket name, the index name, and I said, create index if it doesn't exist. But that process took a few minutes, so I figured I can comment it out because it exists already. And now I'm just connecting to the vector bucket. So the only difference is between this connection string versus previous is I'm not defining the document chunks because they're already existing in the vector bucket. And for create index if not exist, I stated false in there. That's it. So now I've made my connection to my vector data store. And now I'm defining this function where I say, let's query by document type. And I take in my vector store variable and also the actual query followed by the type of document it is. Is it EC2 or serverless? Remember, based on our metadata tag. And then from here, I'm literally taking in the vector store, performing a similarity search. If you recall above, we default to cosine for the distance metrics, and the other option was Euclidean. And I'm literally saying, hey, pass the retriever the following query, return the top 3 matching results, and filter by the document type. So if the doc type equals followed by the document type parameter, I send it, then we return the results. Here I'm executing a couple of search results. I'm saying, hey, send it a vector store with the query just called instance types. We want to search against the EC2 metadata tag doc type, and we'll see the results here. And the same thing, I'm sending another query called Lambda functions with the serverless doc type. And let's see the results. So we're going to execute both of these queries. And you see 3 documents were returned. So if we just look at the serverless results, what was returned from a serverless perspective, you see the document IDs, and then you'll be able to see the metadata information is all serverless, right? And from there you further slide down and you see the actual page content. So this is the actual content that the LLM is going to take in as context and synthesize on. And we can do the same for the EC2 results, excuse me, and we see that as well. Now we know our retriever is working. So what I want to do now is turn this retriever into a tool for agentic purposes. So I'm basically putting the tool decorator. This comes from the import that I specified above from Strands Agents, import agent and tool. And, so obviously you have to install the library of Strands Agents and give it a tool decorator. And you need to provide type hints for your Python function along with the doc string defining what the function does. From here, basically, I'm saying we take in a query and the doc type is optional, but if we provide one, these are the elements that you have to choose from, EC2 or serverless, and we're filtering based on document type, saying, hey, based on this query, search against the following document types on the retriever, and we're sending this information, the filter dict, to the actual retriever. And if there's no matching results, then we say no documents found. If there are, then we're going to display it within this Python list that we're displaying the full variable. So I run that, and now I'm going to wrap this function as a tool, and I just specify it in my agent. So I'm going to be using the Claude 3 Haiku model, and then I'm just specifying a small temperature. But for the tools, I've literally took the name of my function with the tool decorator and just placed it here as a Python list. And if I was adding additional tools, I would just put comma in the additional tools. And now let's test out our Strands agent. So I'm saying, what are the EC2 instance types? I'm sending it this query. The agent's going to route this query to the appropriate documentation based on the metadata filtering that I had typed in. And it knows that it's about EC2 instances, and it provides me a millisecond response. Now I'm saying, tell me about the Lambda functions, and it knows to do that as well. So it's routing to the appropriate document category, which is our AWS function. So this is a great way, the metadata filtering is a great way to actually segregate content from each other. So now, what did we do? We essentially, in a few minutes, created a serverless RAG, right? We used S3 as our vector store. We used the Strands agent to actually turn this retriever from the S3 vector store as a tool and further turn it into an agent. And now we queried against it and we see we're getting good results. This is all a 100% serverless architecture and extremely low cost for prototyping purposes. So I hope you enjoyed this demo, and happy coding. Take care.